Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Amirul Aizad bin Muhammad Shahrani, and my partner of this project, Nur Syairah binti Muhammad Puan, also my beloved supervisor, Dr. Safan Najasat Al-Humairi. I'm taking Bachelor in Engineering, Technology, Electrical and Electronic in Management and Science University, MSU. I'm going to present my final year project that's called River Water Quality Robot Embedded with Real-Time Monitoring System Design and Implementation. Next, we go to problem statement. Nowadays, we know that water waste is defined as the flow of used water from home, business, industry, commercial activity, and institution which are subjected to the treatment plants by a carefully designed and engineered network of pipes. So even though automation play a vital role in all industry application in the proper disposal of sewage from industry and sewage cleaning is still a challenging task. It may cause danger to aquatic habitat and environment with the river pollution. Therefore, as a solution, we have river water quality robot embedded with real-time monitoring system design and implementation to solve such this problem. Next, we go to objective. We have two objectives. Objective number one is to design a water quality monitoring robot using pH chemical sensor and IoT as a communication system. Then, next objective is to record the amount of garbage removed from the waterway in purpose of providing a better environment to aquatic animal and human life. Then, we go to the block diagram of purpose project. In phase number 1, we have two inputs such as solar cell and wind turbine that will be as a power source. In the phase number 2, we have Bluetooth module and mobile remote apps for this project to make the project move in the river and also data collection. For the phase number 3, we have Wi-Fi data cloud to send the reading of pH sensor, garbage sensor and also voltage sensor to the mobile application. Therefore, we go to the next is the significance of the river water quality robot embedded with real-time monitoring system design and implementation. This project have 3 sustainable development goals such as SDG number 7, affordable and cleaning energy, SDG number 9, industry, innovation and infrastructure, and also SDG number 14, life below water. Then, this river water quality robot embedded with real-time monitoring system design and implementation will make all the river in Malaysia will be clean and will be the cleanest river in the earth. Therefore, with this method, all aquatic animals will be safe condition. Next, we have the flowchart of the purpose project. As you can see, all the system are provided here. How the system move and we have the initial power as a source, and then we go to the microprocessor as a data collector for the pH sensor and also garbage sensor. When it have a reading, it will send to the mobile application. After that, this is my final prototype of this project in the 3D design. As you can see from the front view, we have a wind turbine, level sensor, smart trash, and also we have a solar cell and circuit board. For the back view, we have a monitoring drone to monitor the project for the long distance, and also we have a pH sensor. Next, we have the sensor specification. First, we have pH sensor. The task is to measurement of hydrogen ion concentration in the liquid solution. Next, we have temperature sensor, SEAL DS18B20 to water temperature level. Next, we have Rodobo Sense 66 ultrasonic waterproof sensor GSN SR040 to garbage level. Next, we have voltage sensor for battery capacity level. This is my final prototype that shows the top view of project and also front view of project. How does my project work? When the project released at the river, the project start to work with the pH sensor that will detect the chemical that cause pollution in the river. The result will be sent to the mobile application if there is any chemical that cause pollution. Then, the project also have garbage sensor that the project will collect all the sewage in the river, and if the sewage is full in the garbage, the sensor will send the signal to the mobile application. After that, behind the project, I have the plate that can make a drone to land behind the project, because the function of the drone is to monitor the project for the long distance. Now, I'm going to show the demonstration video for the project. Hi, Assalamualaikum. My name is Mohd Amirul Aizad from Shahrani. Today, I'm going to present and demonstrate my project that's called Micro River Water Quality Monitoring Robot using IoT system and pH sensor. Let's go. First, we will go to the garbage sensor that we will show you how it's works. Now, we have the garbage. In example, in the sewage, when the garbage to here, the sensor will detect and the buzzer will come. And the plastic also. So, if there any rubbish inside all the garbage provided in the project, they will collect all the rubbish and will send all the detector of the sensor to the buzzer, and we know if the rubbish is full, the buzzer still toggle. Now, the last part is the pH chemical sensor. Now, this is the pH sensor. I have distilled water and the river water as a sample. So I use my mobile phone to connect with the Bluetooth to the system. So now for the distilled water, I put it in the distilled water. You can see the reading is the 5. That means the water is normal. It's safe for us. Okay. Then I switch up with the river water. The result in the river water, they go show that the value is 4. That means is also okay but not too good for us. Okay, now I will show you the graph that I make it for the 30-minute reading for the pH sensor. This graph is for the distilled water that I take in 30 minutes, and also the graph for the river water that I take in 30 minutes.
Hi, Assalamualaikum. My name is My title project is Clean Energy, a low power generator using wind turbine and solar cell. So this is my project that extended from my colleague project. My part is to generate the power from the project by using solar cell and wind turbine. So let me move to the wind turbine. The wind turbine is to generate the electric to supply the power at the side of the river. The wind turbine also can rotate and move the project. This is how we rotate the project by connecting the Bluetooth, and we can go to the front, and this is the right side, and this is the left side. Now let's move to the solar panel. I already installed the solar panel using the Wi-Fi, so the person that in charge in the solar panel and the wind turbine can record the solar panel how much is the voltage from the hotspot. We can use this blink. This is the blink that connect with the solar, and the person in charge will see how many voltage in this battery.
Next, this is the mobile application controller that to control the project when the project at the river, and Bluetooth module system to take the reading of the pH chemical sensor. Then, this is the mobile application for the power generation monitoring for reading of the solar cell that we can check the reading of the power system of this project. After that, as you can see, A is the location of geographical of project at Damansara River, Shah Alam, Malaysia. Then for the B, We have the reading of the pH level, that measurement versus time for 30 minutes with a sample of the river water and distilled water. Then, for the C, we have measurement versus time for the temperature of the power generation. Then, we go to the market potential of this project. For the market potential, it can go to the Government of Selangor, Jabatan Pengairan and Saliran Malaysia JPS, Jabatan Alam Sekitar Malaysia and also Tenaga Nasional Berhad TNB. For the market value of this project is around RM1,500 to the RM2,500. For the conclusion, this project provides an efficient, cost-effective IoT framework for monitoring water quality in a real-time system. The Arduino Uno target board and Wi-Fi module are successfully interconnected to the several sensors to provide real-time data. An autonomous river robot attached with the multi-sensory and self-power generation was under monitor the water quality. The measurement parameter were also monitoring use the special design mobile application. The pH measurement value range from 2 to 4.6 for the Damansara River Shah Alam Selangor, Malaysia, which considered high acidic. Furthermore, the temperature record was fluctuated based on the atmosphere temperature. Thus, IoT has significantly reduced the risk from the climatic fluctuation and ensure growing and health for the aquatic and underwater life. Besides that, aqua system purpose design be the automate use the Internet of Things, reduce energy consumption of the labor cost. Lastly, I want to thank to my supervisor Dr. Safa and also my partner Nur Shahira that support me from the start of my project until finish. That's all for me. Thank you very much. Assalamualaikum.